Morning, my chemistry faithful. Today on video 7, we're going to talk about electron excitation and emission. This is the basis for our lab, and this is information that generally shows up on the Regents exam. So when I say we've started the course in earnest, I mean it. How electrons behave around an atom. First, they can move freely within their orbitals. And if I add enough energy, generally heat, I can get an electron to jump from one energy level to another, and that is what this picture is showing you in this piece right here. So this is the energy coming in, and this is the electron jumping up an energy level. So this can happen. It will change the electron configuration. We'll see in the next video. Okay, and if it happens, and so specific step. Okay, and then I produce this bright line spectra because I need a specific amount of energy to get from one place to the other. So the theory is, and this is through many experiments, I can't end here and have it work. I have to, it's like taking a walk up a flight of stairs. The electron has to get all the way to here. So it needs at least that much energy. And in this picture, it actually had enough energy to get all the way to two steps. And sometimes when you're in a hurry, you kind of take 2 steps at a time, but you can't take a half a step. So that's where the specific amount of energy comes from. Okay, so now that energy, we measure it because what happens is you give the electron energy, it jumps up to an energy level, and it only stays there for like a millisecond, and then it falls right back down to ground state. And that's the next picture where it falls back down, and notice energy then leaves. Well, that exact amount of energy it took to bring it up is given off. And that energy given off will translate into a different wavelength. Different wavelength means a different colored light. So now I get this spectrum of light. Okay? And if I continue to keep adding energy, I can create the whole spectrum. So we'll only get 1 point in lab because we're going to use a Bunsen burner flame. We don't have a way to kick that up and then to kick that up even hotter and hotter. So we're going to use the same amount of energy, and we're just going to use multiple different atoms to see the different colored lights from the first jump. Okay, so this is the idea that if I continue to give it more and more energy, I'm going to continue to give out different colors lights, and that's going to actually act as a fingerprint, and that's the bottom picture. So you notice this is the absorption spectrum on top, and then the emission spectrum is what's given off. And if you look, those pieces are literally almost just cut right out. So they're the opposites, right? The emission energy is what's given off, and then you see this band, and the band has like 2 purples and then a blue and then this like light teal and then a red. Well, at those spaces and at those colors, that's a specific element, and then the next element is going to have a different actual pattern to its light, and I can actually differentiate atoms one from another, and this is much like density. It's an intrinsic value. Okay, and now we get to play games like, and this is, let me make sure I didn't miss any notes. Okay, good. Just making sure, not getting ahead of myself. And so then we can play games with these spectrum like this in a problem very similar to what you would see with the gel electrophoresis with DNA in living environment. We just got to match the bands up. So if I have unknowns, I have to have all the bands of the known to make sure it's in there. Okay, so let's do this first one. It says, what element is present in sample W? So we're going to deal with just this guy here. And we got to start matching up bands. Well, I see this band in W, and that goes here. That's good. And then this band in W matches, and 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 this band in W matches. So I definitely have cadmium CD for sure. Now, which one didn't I mark? That's this guy here. Where is there a double band? There's a double band here. Notice he doesn't have anything else. Because if there was a one here, I'd need to have it or it wouldn't be there. Okay? So it looks like I also have sodium in my band. So I have cadmium and sodium, Na. And because those symbols are there, if you don't know them real good yet, I'm just going to use the symbols because they are there, and it's definitely shorter and faster than writing out all the words. Now I'm going to look at X. So X is down here a little bit, and I see right away this double band. That double band, these lines seem to match up, but that double band certainly looks more like that, doesn't it? And then I see this band. Uh-oh, so see, now I got hydrogen possibly too. So maybe these two are overlapping. Ooh, there we go. And then, uh-oh, wait a minute. There's no band here. Okay, so that's not good. And I'm still dealing with X. This band is not there. So that crosses off hydrogen. Hydrogen is definitely not in. Okie dokie. So now I'm going to go back to this one. Oh, instead of this one, oh, wait, maybe it's this guy here. Oh, that makes sense. Oh, good, and these two match. Good, good, good. And this one here matches up here. And this one here matches here. And these two match here. So I have everybody in potassium. I have everybody in lithium. So there's definitely potassium and lithium. You're going to like lithium when you do the lab. Lithium burns bright, bright red like this marker. Bright red. It's fun. I like it. All right, I'm going to keep going. Sorry if the video goes long, but I want to make sure I had time to at least show you how to do all of these. Why? Here we go. And this could easily be a multiple choice question. All right, so I don't know if it's this one or this one. This guy is definitely here. And this guy is definitely here. And this guy is definitely, that makes sense. That's all that. And then this guy is not here. It's here. So now I know it's those two. See how we did that? And that matches up here. Good. This one's up. Oh, good. So everything's falling into line now. This one's, oh, here and here. That is not a double band. And then this one, perfect. So I see I have helium and lithium in this one. You guys getting the hang of this? Sorry if I'm boring you. I have a feeling that I probably don't need to do these bottom two after doing 3 of them. So I'm going to go ahead and do it anyways because why not? Let's see. List all elements present in Z. So now we're going to the bottom one here. All right, this guy could be this or this. I'm not really sure. This guy here is here or here. This guy here is here. And this guy is here. Uh-oh, here we go. Things are getting crazy. Oh, I got another one there. And there. And let's see. This guy looks to be here. And this guy would be here. And this guy would be here. And this guy is here. And this guy is here. And this guy is here. Okay, so looks like I have 3. I don't have this or this, so I'm going to go ahead and cross this guy out, the top one out. Lithium is not in this, but this one looks like I have 3 elements, and if you can prove me wrong, I'll take it because this one could be double banded, right? That could be both. So I have 3 of them listed. I could definitely have Na, and I have He, and I have hydrogen. And notice that this guy is not present. And this guy here is definitely not present. So it's not cadmium either, so we can't use CD. And this guy's out. CD is out, so I have 3 in the 3 elements in that last sample. Okay? And that says, how is the bright line spectrum produced by atoms? Well, I'm going to verbally say this. Make sure you're listening. Ready? Energy is given in. Energy is given to the atom. The electron becomes excited. Then the electron falls back to ground state and gives off that same energy in the form of light. That is how the bright line spectrum is produced. And that is what you need to be able to recite verbatim. And with that, we're out.